In this video, we're going to look at these rational functions, determine the y-intercept, the factored form, the domain, put it in reduced factored form if it's different from the original factored form, and determine the coordinates of any holes in the graph, determine any vertical asymptotes, and determine any x-intercepts. Okay, so for this first one, if I want to get the y-intercept, I simply evaluate the function at 0. So the only thing I'm going to have left in the numerator is 6, and the only thing I'm going to have left in the denominator is 14. Of course, that will reduce to 3/7. So my y-intercept is the point 0, 3/7. Next, let's get it into factored form. I can see it's x squared by itself. Are there two numbers that multiply together to give me positive 6, but at the same time add up to give me negative 5? Yes, there are. And that's going to be negative 2 and negative 3. And are there, because it's x squared by itself, are there any two numbers that multiply together to give me positive 14 but add up together to give me negative 9? Yes, negative 7 and negative 2. So this is my factored form. Now, if I'm going to look at the domain, I do not cancel. Do not make any cancellations if you're going to look at the domain. The domain here, well, when it's in factored form, you can see that x is not allowed to be 7 and x is not allowed to be 2. Now, if you're required to put that in interval form, then where would this look like on a number line? Well, on the number line, it can be anything except 2 and 7. And so how would you write that in interval form? Well, going from left to right, start at negative infinity, and then go up to, but not on to 2. You've got to jump over 2, then everything between 2 and 7, then you've got to jump over 7. So this is how you would write it in interval form. In web work, you'd have to use INF. Infinity. Okay. All right. So now, what is the reduced factored form? We can see that we have a cancellation here. Now, it's important to understand I could only make this cancellation if x is not equal to 2. So I have to include that. X is not equal to 2. Otherwise, I'd have 0 over 0. Since I made one cancellation, the x minus 2, there's going to be one hole. Now, what are the coordinates of that hole? Well, the x coordinate is going to be 2. And the y coordinate is going to be my formula with 2 substituted inside there for x. So that's going to give me 2 comma negative 1 over negative 5. Well, the negative signs cancel, and so there will be a hole at 2 comma 1/5. That gives you the coordinates of the hole. Any vertical asymptotes? Well, vertical asymptotes, you look at any real zeros of the denominator after cancellation. So there's one vertical asymptote. Its equation is x equals 7, because 7 is a 0 of the denominator. And what about the x-intercepts? Well, we look at any zeros of the numerator, and there is one. 3 is a 0 of the numerator. It'll make it 0. So you have to look at that after cancellation. And I have one x-intercept, 3 comma 0. So that's the one for the first one, F. Let's look at this next one. Okay, if I'm going to get the y-intercept for G, then I look at G evaluated at 0. So when I replace x with 0, I'm going to be left with 15 in the numerator and negative 10 in the denominator. And that will reduce to negative 3/2. Because 15 is 5 times 3, 10 is 5 times 2. So my y-intercept is the point 0, negative 3/2. All right, now what about factored form? Well, it's not x squared by itself, so I can't use the same trick I used up here. 2, its factors will be 1 and 2. Now what about 15? It's positive 15, but because of a negative sign there, both of my factors will have to be negative. If both of them are positive, then when I try every possibility, everything will be a plus sign. So what could I have for positive 15 where both of them are negative? I could have negative 3 and negative 5, or negative 5 and negative 3, or negative 1 and negative 15, or negative 15 and negative 1. Let's see which ones work. So I'll try this pairing first. It's the outer product plus the inner product. Negative 5 plus negative 6 is negative 11. And that does not equal negative 13, so it's not that one. All right, the outer product is negative 3. The inner product is negative 10. So negative 3 plus negative 10 is negative 13, and I have found the pairing that I need. So this will factor, and the way it will factor is I'll have 1 times x and 2 times x there, and then negative 5 here, and negative 3 there. And if you don't trust that, you can always go back and FOIL that through, and that should give you what you have there. All right, what about this one? Well, 3, I can have 1 and 3. And what about negative 10? Well, I could have negative 5 and positive 2, or 5 and negative 2, or negative 2 and positive 5, or positive 2 and negative 5. Or I could have 1 and 10, negative 1 and positive 10, negative 10 and positive 1. Yeah, there's more. Alright, so there's quite a few possibilities there, but as soon as I find one that works, I'm done. Alright, I'm going to take outer product plus inner product. So 2 plus negative 15. Positive 2 plus negative 15 is negative 13. I was very, very lucky there. The first one works. The first pairing works. So this will factor, and I'll have 1 times x and 3 times x there. And then negative 5 goes in there, and positive 2 goes in there. So this will factor as x minus 5 and 3x plus 2. Okay. Now, can we get the domain? This is the factored form. So to get the domain, we do not do any cancellation. Now I look at the denominator. What are the zeros of the denominator? Well, 5 is a 0 of the denominator. And negative 2/3 is a 0 of the denominator. Now, if you don't see that just yet, then what you have to do is solve 3x plus 2 equal to 0 for x. Subtract 2 from both sides. Divide both sides by 3. So what value of x will make this 0 negative 2/3? So these are my zeros of the denominator before it's factored. So the domain is x is not equal to negative 2/3, and it's not equal to 5. That's a correct answer. However, if you were required to put that into interval form, then again, what would it look like on the number line? Well, it can be anything except negative 2/3 or 5. And so in interval form, going from left to right, there's no left limit. And I come up here and I have to jump over negative 2/3. Then I want everything between negative 2/3 and 5. And then I need to jump over 5. So that would be my domain in interval form. Okay. Now, what about reduced factored form? Well, I can make this cancellation. I can only do that if x is not equal to 5. So that has to be part of my reduced form. So what's left is 2x minus 3 and 3x plus 2. So I made one cancellation, so there is one whole. Where is the whole? Well, we have one whole, and its x-coordinate is 5. What is the y-coordinate? Well, you take 5 and you plug it back into the reduced formula. So I'm going to have 7 in the numerator, and I'm going to have 17 in the denominator, and that's in reduced form there. And so that is the coordinates of the whole, and there's one whole. Any vertical asymptotes? You look at zeros of the denominator after cancellation, and we saw that negative 2/3 is a zero of the denominator. So I have one vertical asymptote. Its formula is x equals negative 2/3. Don't write negative 2/3 on its own. That's not correct. This is a formula of a vertical line. Now what about the x-intercept? The x-intercepts are found at zeros of the numerator after cancellation. And so hopefully we can see that 3/2 is a zero of the numerator. If not, if you can't see that, solve that for x. Add 3 to both sides. Divide both sides by 2. So 3/2 is a zero of the numerator after cancellation. So I have one x-intercept, and it's a point, and that's what its coordinates will be. Give the fraction, not the decimal approximation. Okay, what about this one? This one is already in factored form. So let's get the y-intercept. So my y-intercept for this guy is found at h of 0. So when x is 0, the numerator is going to be, well, that's going to be negative 2. 0 minus 2 is negative 2. 0 plus 1 is 1. And 3 times 0 minus 2. And my denominator is going to be 0 plus 1, which is 1, times 5 times 0 plus 3, which is 3, times 0 plus 1. Okay, I'm going to have 3 in the denominator, and I'm going to have positive 4 in the numerator. So my y-intercept is the point 0, 4/3. That's my y-intercept. All right, the domain, well, what are the zeros of the denominator? I can see that the zeros of the denominator, what will make the denominator 0? Well, if x is negative 1, if x is negative 3/5, again, or if x is negative 1, so it's repeated. So the domain is always done before any cancellation, and so for the domain, x is not allowed to be negative 1 or negative 3/5. Okay, that's a correct answer. What if you're told to put it in interval form? Well, where would it be on the number line? Anything except those two. Anything. And so now going from left to right, there's no limit here, but we got to skip over -1. And then continuing, we've got to skip over -3/5. But once we're past -3/5, we're good forever. So that would be our domain in interval form if that's what we were asked. Okay, now reduced factored form. I can cancel that. And that seems to be all I can cancel. So there will be one whole. So the reduced form is going to be x minus 2 times 3x minus 2 over 5x plus 3 times x plus 1. There will be one whole. Now, I could only do this cancellation if x was -1. Okay. So, what we do next here is, let me correct this. This was actually a misprint because I wanted one where there was 2 holes. So it's early enough to where it's still not too bad. So I could only make this cancellation if x was -1, but now I can still have another cancellation I can make here. And so my reduced form I have to have that x is not equal to -1, and to make this cancellation I have to have that x is not equal to 2. So we actually had 2 cancellations here. And so my final factored form, reduced factored form, is going to look like this. So I made one cancellation here that I could do if x was not equal to -1. I made a second cancellation here that I could do as long as x was not equal to 2. So in this case, there will be 2 holes. What are their coordinates? Well, the first one has x coordinate -1. The second one has x coordinate 2. Now, what are the y coordinates? Well, for this one, you plug -1 into the reduced formula. For this one, you plug 2 into the reduced formula. Okay. So I'll have -5 in the numerator, and I'll have -2 in the denominator. Those negative signs will cancel. So that's the first whole. For this one, that'll give me 4 in the numerator and 13 in the denominator. And that's in lowest form. So those are the coordinates of the 2 holes. Now, vertical asymptotes are found at real zeros of the denominator after cancellation. So we can see that -3/5 is a 0 of the denominator. Again, if you can't see it, you're going to have to solve that and get x by itself. And you should have x is -3/5. So that will make it 0. So I have one vertical asymptote. Its equation is x equals -3/5. So we don't want to put -3/5 by itself for the vertical asymptote. That's not correct. What about x-intercepts? X-intercepts are found at the zeros of the numerator after any cancellation. And I can see here, if x is 2/3, that will make the numerator 0. Again, if you don't see that, solve that for x, and you'll get x is equal to 2/3, so 2/3 is a 0. So I have one x-intercept, and its coordinates are 2/3, 0. Okay, what about this one? K. All right, so for the y-intercept, I find k evaluated at 0. So when x is 0, I'm going to be left with -3 in the numerator. When x is 0, that'll become 0 minus 11, which is minus 11. That will become 0 minus 9, which is -9. And I can write -9 as -3 times 3. And so after cancellation, I'm going to have that. So my y-intercept is the point 0, -1/33. Okay. Now, what about factored form? Okay. Whenever you have x squared minus a number, it will factor as x plus the square root of c times x minus the square root of c. It will always factor, always. So in the denominator here, x squared minus 11 will factor as x plus the square root of 11 times x minus the square root of 11. X squared minus 9 will factor as x plus the square root of 9 times x minus the square root of 9. But 9 is nice. The square root of 9 is 3. So this will factor as x plus 3 times x minus 3. Now, what about the numerator? Well, again, if I've got 1 and 2 are my factors for 2. What about -3? I could have 1 times -3. I could have -3 times 1. I could have -1 and +3, or +3 and -1. Let's see if these work. So outer product plus inner product. -3 plus 2 is -1, and that does not equal -5, so that doesn't work. All right, let's look at this pair. Outer product 1 plus -6 is -5. I have found the one that works, and when you find one that works, you don't have to look at any more. So this will factor. So I'll have 1 times x here, and I'll have 2 times x there, and then -3 will go in there, and then +1 will go there. Okay, so what is the domain? Well, before any cancellation, what are the zeros of the denominator? I can see 3 is a 0. I can see -3 is a 0, and square root of 11 is a 0, and the negative of the square root of 11 is 0. Okay. So the square root of 11 is irrational. Where is it? So it's 3.3 something. Now I'm going to leave my answer as exact, but I just want to see where it is on a number line. So square root of 11 is a little bit bigger than 3. So on the number line, so my domain, x is not equal to negative square root of 11, -3, positive square root of 11, and 3. So on the number line, they would be located sorry, 3, and then square root of 11. Okay, so from smallest to largest, that would be the order on a number line. Now, if you're writing it like this, it doesn't matter what order it is. So you can't have 0 in the denominator, so x is not allowed to be any of those. But now on the number line, where would they be? Well, this would be something like negative 3.3. So it would be to the left of negative 3. Then we have positive 3, and positive square root of 11 would be something like 3.3. So that's where they'd be on the number line. Now, why do I have them on the number line? Well, if you're not used to interval formation, and they want you to put it in an interval form, then it's easier to see if you have it on a number line. So going from left to right, we got to jump over the square root, the negative of the square root of 11. Then anything between there and negative 3, but you got to jump over negative 3. And then anything between negative 3 and positive 3, got to jump over 3. Anything between 3 and square root of 11, then you got to jump over square root of 11 and then go on forever. Okay, it's a long interval form, but sometimes it wants to know interval form. That's correct. That's a number line presentation. That's interval form. Okay. Now, how many holes will there be? There will be one hole because I make one cancellation. So in lowest form, this is 2x plus 1 over x plus the square root of 11 times x minus the square root of 11 times x plus 3. But we have to include x is not equal to 3 because I made this cancellation when x was 3. So there's one hole. Where is it? It happens when x is equal to 3. And what is the y? So the x coordinate is 3. The y coordinate is, well, I plug in 3 into these. Oh, 3 plus 3. Okay. So I'm going to have 7 in the numerator. I might FOIL that one out because that'll give me 9 minus 3 times the square root of 11 plus 3 times the square root of 11. They cancel. And then square root of 11 times the square root of 11 is 11. So I've got a negative sign there. So I have 9 minus 11. 3 plus 3 is 9. Or you can put the whole thing in a calculator. So I'm going to have negative 2 times 9. So that's where the hole is. That is where the hole is. Okay, vertical asymptotes are found at real zeros of the denominator after cancellation. So my vertical asymptotes are going to be x is equal to the negative square root of 11. That's a line, and that's the exact answer. X is equal to the square root of 11, and x is equal to negative 3. Those are my exact answers, and I have 3 vertical asymptotes. X-intercepts are found at zeros of the numerator after cancellation, and we should be able to see that negative 1/2 is a zero of the numerator. What will make the numerator equal to 0? So negative 1/2 is a zero of the numerator. After cancellation, that's all there is, and so I have one x-intercept. It's negative 1/2 comma 0. And then the last one is this one. What is the y-intercept? Well, if x is equal to 0, I'm left with negative 15 in the numerator, and I'm left with negative 20. So the negative signs cancel. 15 is 5 times 3, and 20 is 5 times 4. And so my y-intercept is 0,3/4. Now, what about factoring? This one here in the denominator, two numbers that multiply together to give you negative 20, but add up to give you positive 1. So that'll be positive 5 and negative 4. How do I factor that one? I can look at the graph and see if there's any x-intercepts that are whole numbers. So looking at the numerator, x cubed plus 5x squared minus 3x minus 15. All right, I'll do a zoom 6. Okay, and there seems to be one there. I'll refine the window. Let's see what we have here. All right, right here is one that looks to be a whole number. So negative 1, 2, 3, negative 1, 2, 3, 4, 5. It looks like we have an x-intercept at negative 5. What good is that? Well, from Math 100, it looks that negative 5 is a 0 of the numerator. So I'm going to test that with synthetic division. And it is. So the numerator will factor. It'll be x minus the number in the box, so x minus negative 5, times the quotient. So that's our remainder. The quotient, that's your constant, that's your coefficient for x, that's your coefficient for x squared. Now remember, we have that rule. If it's x squared minus a number, it always factors. So this will factor. So I get x plus 5 times x minus square root of 3 times x plus square root of 3. Okay, let me write that down here better. So x minus square root of 3 times x plus square root of 3 all over this. Now what's the domain? Well, before any cancellation, x is not allowed to be negative 5 and x is not allowed to be 4. And you should be able to get that into interval formation. Okay, now in lowest form we have one cancellation, so there is going to be one whole. So in lowest form, I'm going to have x minus the square root of 3 times x plus the square root of 3 all over x minus 4, but I must include, I only made this cancellation if x was not equal to negative 5. So I have one whole, and it will be at negative 5. What is the y coordinate? Well, you got to plug in negative 5 for x into the reduced form. Okay. In the denominator, I'm going to get negative 9. In the numerator, I'm going to get positive 25 when I FOIL it. Then minus 5 times root 3 plus 5 times root 3. So they will cancel. And then I'm going to have negative root 3 times root 3, which will be minus 3. So the whole will be at 25 minus 3 is 22. That is where the whole will be. Okay, now what about vertical asymptotes? Vertical asymptotes are found at the real zeros in the reduced factored form. There will be one vertical asymptote, x equals 4. X-intercepts, they're found at real zeros of the numerator in reduced form, and I can see here that I'll have one x-intercept at square root of 3 comma 0, and the second x-intercept will be the negative square root of 3 comma 0. That's my exact answer. If you give a decimal approximation, it's no longer exact because this is an irrational. So that has gone through just about every type of example you could imagine.